Hi, everybody. Welcome to the last little bit of information in this course. So I wanted to do is just spend a little bit of time, not a whole lot of time, talking about air pollution. Pollution is obviously a big deal in urban areas where there's lots of different factors, urban emissions, cars, trucks, factories, fire pits, heating, cooling systems, and all of that can kind of add up when combined with particular weather as well as geography to really create some pretty big pollution problems. So I'm going to go through this pretty fast, but I do want to at least introduce you a little bit to air pollution, what causes it, what are some of the main types of pollutants, and then how weather plays a role in that. Now, before I begin, I do want to acknowledge this PowerPoint presentation. I adapted it from Professor Craig Clements of San Jose State University. I want to make sure I give him credit for what he did here. He's also the director of the Interdisciplinary Fire Research Lab at San Jose State University, one of the top fire research labs in the entire country. So he knows a thing or two about air pollution and the role that topography, the role that geography, the role that weather plays in pollution. So pretty good source. Those of you who are following along using our textbook, this comes from chapter 14 in the textbook. And let's jump in. So what I want to talk about, first off, I'm going to split this up into four main categories. Primary pollutants, secondary pollutants, air quality, and then the role that weather plays in all of this. So first I want to talk a little bit about what's actually in our air. What are you breathing right now? Now, I'm sure that you already know from earlier in the course that the bulk of what you're breathing is nitrogen. Right, about 78% of what you're breathing is nitrogen. 21% is oxygen, but then what makes up that remaining part of what you're breathing? Those include things such as ozone, nitrous oxide, nitric oxide, nitrogen dioxide, carbon monoxide, carbon dioxide, sulfur dioxide, and then this little guy over here called a volatile organic compound. And these can also include things like methane and a few other nasty things. But you're actually breathing these right now. Now, normally, the amount of these in the air really doesn't cause any problems. But on certain days and in certain conditions, one or more of these components can actually become a little too present. Now, with that said, each one of them has different sources. And then there's other things that you're breathing as well, things like aerosols, black carbon, soot, smoke, pollen. Those are other things that you're breathing in as well. I'll briefly talk about particulate matter later in this lesson. So there are several different types of pollutants, and a big thing that affects them is where they come from. So this includes things such as primary and secondary pollutants. Primary pollutants are pollutants that we actually pump into the air. Secondary pollutants are pollutants that actually form some kind of process, some kind of natural process that's occurring, or some kind of chemical process in the atmosphere. Basically, they take what we pumped into the atmosphere and change it into something else. Gases and particulate matter. So some of the things I mentioned, carbon monoxide, nitric oxide, nitrogen dioxide, those are gases. And then things like ash, smoke, pollen, things that actually have like a visible component to them. Those are what are called particulates. And particulates typically have one of two sizes to them. Now, that's not to say that these are the only things, but The ones that we tend to look at are PM10. Those are particulates with a diameter of 10 micrometers, and PM2.5, which are really, really, really tiny, little fine-grained particulates with diameters of around 2. And PM10 and PM2.5 actually can cause many health problems. So, as I mentioned earlier, pollutants can be classified either as primary or secondary pollutants. Primary pollutants are pollutants that basically have been pumped into the atmosphere due to human activity. Things such as combustion. Combustion creates a lot of carbon dioxide that gets pumped into the atmosphere. However, in many cases, at least a little bit of that carbon does not react with 2 oxygen molecules, but only 1 to produce carbon monoxide. Also, nitrogen in the air reacts with oxygen to produce nitric oxides, nitrogen oxides. Incomplete combustion of things like coal can produce sulfur oxides, volatile organic compounds, things like methane, and then particulate matter. And then over here, this shows the primary sources. And as you can see, the main ones really are transportation, as well as combustion. So basically burning fossil fuels and what comes out the other end. Not only does the burning of those fossil fuels create carbon dioxide, which then contributes to climate change, but many of those fossil fuels are impure, meaning that in addition to carbon, they have other impurities in with them, things like nitrogen and sulfur and so on, and those can actually create many of these different pollutants as well. So first, let's talk about primary pollutants. Primary pollutants include things such as carbon monoxide, which can actually be very dangerous in the home. And the reason why is carbon monoxide can essentially suffocate you. And it's a silent killer. It's tasteless, colorless, odorless. You can be in a room that seems completely safe, not notice any changes in smell, taste, or anything like that, and all of a sudden, bonk, pass out and go away, because carbon monoxide is really difficult to detect. Some of the sources of carbon monoxide, in particular, fossil fuel combustion, things like burning gas, sorry about that. Burning gas, incomplete combustion, where instead of reacting with 2 oxygen molecules, sorry about that. My allergies have been kicking up while I've been recording today. Okay, I think that's it. It's organic. That's what happens sometimes while recording. There's no point in hitting stop and going back to the beginning. So let's keep going. So some of the sources include incomplete combustion, biomass burning. So the burning of things like wood, the burning of things like crops, grasses, shrubs, trees. Those are all things that those are all things that can contribute to the creation of carbon monoxide. Typically, carbon monoxide concentrations are really, really low. Significantly lower than carbon dioxide, which has concentrations of around 400 parts per million. Concentrations of carbon monoxide are typically lower. And one of the reasons why is because it gets diluted out very easily in the atmosphere. Um, that being said, in areas where there's a lot of combustion happening, so on freeways, roadways, um, in tunnels, parking garages, um, concentrations can jump up significantly to, in some cases, over 100 parts per million. This can become a big issue for people's health because carbon monoxide is poisonous. It essentially suffocates you. Other primary pollutants, sulfur dioxide. We've talked about sulfur dioxide before when we've talked about acid rain, when we've talked about volcanic eruptions. Sulfur dioxide is another thing that oftentimes comes from incomplete combustion as well as impurities when burning fossil fuels. It is also a colorless gas, but it's more detectable. Once you get to certain thresholds, you can actually begin to notice a taste and then begin to notice a strong odor. And sulfur dioxide, smells really bad. One of the biggest sources of sulfur dioxide includes the burning of coal. I haven't talked a lot about it in this class, but when burning coal, the impurities inside that coal, not just carbon, but also sulfur, nitrogen, and so on, those things oxidize as well and create things such as sulfur dioxide. Volcanic eruptions are another big source of sulfur dioxide, as well as automobile tailpipes, gasoline. When gasoline is combusted, there's a little bit of sulfur dioxide in it. Here in the troposphere, for the most part, background concentrations are very low, anywhere from 10 parts per trillion to 1 part per billion. And then in polluted air, it's a little bit more than that. But in either of these cases, usually not enough to get that smell or that taste that you would get in higher concentrations. One of the big primary pollutants, though, that we really worry about and that we actually monitor very regularly is nitrogen oxides. Things such as nitric oxide and nitrogen dioxide. These things come from fossil fuel combustion. These things come from fossil fuel combustion as well. Impurities in that coal and that gas. Nitrogen is one of those impurities. Basically, what happens is when you end up getting nitric oxide and nitrogen dioxide in the atmosphere, those things, when reacting with sunlight, can actually increase the amount of ozone in the atmosphere, which I'll actually talk about in the next video. We tend to group these two things together into what is called NOx. NOx is basically the sum of nitrogen oxide plus nitrogen dioxide. Concentrations can range from as low as 20 parts per trillion to as high as 50 parts per trillion, and even higher in urban areas. One of the reasons why it's so common in urban areas is because there's a lot of combustion happening. There are, right now, lots of cars driving around. There are lots of trucks driving around. There are lots of electricity being produced, and those things all burn fossil fuels and release NOx. What's interesting, though, is that NOx concentrations pick up in the morning during commute hours, during everybody waking up and activities kind of going on, but then they drop substantially in the afternoon. The reason why is because sunlight begins to react with the NOx to produce other things, and those other things are what are called secondary pollutants. The last type of primary pollutant I'm going to talk about are what are called volatile organic compounds, or VOCs. VOCs are basically things that um, come from hydrogen and carbon. They're volatile, meaning that they can react to things. Methane is the most abundant of them. Methane is the most abundant of them. And human activities can emit a lot of methane.